Oh, yeah. We had huge tables by which you could figure them out. And actually, they were easier than you think. Because when you take two LLNs, addition outside, multiplication inside, there's a lot of rules. We used to do cool things with them that you guys can't, I don't know, can't even see probably. Find an equation for tangent line of graph of f at a given point. Use the graphing utility to graph the function of the tangent line at this point. C, use the derivative feature of the graphing utility. Just cross out C. We're not going to do that. I don't know what that even is. My fingers are crossed.
Graphing utility.
Graphing utility.
But I can't.
Graphing utility.
Slope fields on my calculator, isn't it?
Yes, you can. I said that. I said some geek in the room is going to come up with a way to do that before too long. So let me tell you in advance it can be done.
I knew I could do that before.
It's the reason why slope fields are never on the graphing part, never part of the calculator part of the test. Because some doofus created this program and put it online so everybody can get it.
No, it comes automatically.
It now does. Okay, fair enough. It used to be you had to go online to get it. Now it's for free. I suspect most calculators can do it because there's something in the new green Blitzer book that shows a slope field that was done on a calculator. So I assume it was actually on the calculator. Okay, I'm going to pull the 1/2 out in front. So far with me? And the rest of this is going to have to get ugly, so I'm going to go f prime of x equals 1/2. This becomes 1 over 1 plus sine squared x times derivative of the inside. Derivative of 1? 0. Plus, oh, crud, I don't know sine.
Oh, yeah.
I have to use u substitution, or I do inners outers? Oh, man, really? So u equals sine x. So this becomes du squared du times the derivative of the inside, which is derivative of sine x dx. This becomes 1/2, 1 over 1 plus sine squared x times, the 0 goes away, I've got 2u, u is sine x, times derivative of sine x, which is cosine x. So now you're going to plug in the point right away. Pi over 4, that's annoying. But pi over 4 is root 2 over 2, correct? And so root 2 over 2 squared would be just 1/2, agreed? So this is 1/2, so this becomes 1 over 2. Let's leave the 1/2 out in front, otherwise you guys will get all confused and confuzzled. 1/2, 1 over 1 plus a half. So far so good? Times 2 times root 2 over 2 times root 2 over 2. We just found that was a half, right? So that's 1/2 times 2. That's just 1, and that whole thing falls off. So I get 1/2 times 1 over 3/2. How do I do 1 over 3/2? Flip and multiply. So this becomes 1/2 times 2 over 3, or just simply 1/3. All that big ugly mess I had with 1/3. That's the slope. So now I go y equals 1/3 x plus b.
What did you say?
I'm going to plug in my point to figure out what b is. X is pi over 3. Y is ln of the square root of 3/2. You might be thinking this is going to get ugly, but it turns out it doesn't. The uglier it gets, actually, the easier this gets. You okay over there?
Yeah.
Okay. So that's pi over 12, right?
Yeah.
Move to the other side, I get ln square root of 3 over 2 minus pi over 12 equals b. So what's my ugly equation? Y equals 1/3 x plus ln square root of 3 over 2 minus pi over 12. There it gets, easier it gets, because you don't have to combine it. Company good? Uh-oh. Okay?
Yeah.
Fall down with a cough. Fall down with a cough. That wasn't fun. Emily, stop picking problems. You pick the non-fun ones. Means you're doing your homework. Hate that. Means you're doing your homework. Hate that.
Can you do 59?
59. 59. 9. Pause this. Actually, that's not. Here we got this one. Okay. 59. 59. F of x equals ln. Oh, I'm going to use the ln rules on this one. Oh my, am I going to use ln rules on this one? There's something divided by something. Division inside is
Subtraction.
subtraction outside. So I'm going to go ln 4 plus x squared to the 1/2 power minus ln of x. So far so good? Don't like that 1/2 power. I'm going to throw that out in front too. 1/2 ln 4 plus x squared minus ln of x. I'm out of funky rules. So now what do? Derivative time. This is going to equal 1/2 1 over 4 plus x squared. Now I'm going to do the derivative of the inside, which is
2x.
2x minus 1 over x. Cleaning up my messes in at least a minimal sort of way, I get 4 plus x squared minus 1 over x. That's probably good enough. I got a 2 in there in both places. I should get rid of that at least. A little embarrassing about 2 over 2. Who asked for this one? Oh, good? All right. Ellen,
What is the absolute value?
65. What's the absolute value mean to us? Oh, wait,
Do you have to do it piece by piece?
I'm a little confused.
I don't know how we do any of the absolute value.
Feels like we lost instructions or something.
Yeah.
It's not a deal.
Nope, I'm wrong. We haven't lost instructions. I'm just losing my mind. I mean, theoretically, they're all absolute value functions. So just be aware of that. So this doesn't change a thing, right? The derivative's still going to be the same. So they're going to be the same. So I look at this and go, okay, something divided by something. Division inside is?
Which
So the absolute
67,
value
sorry.
is 80?
What?
That's 60.
Absolute value means nothing to us.
This is 60.
Absolutely nothing. Has to be part. It has to be there theoretically. Although if it's not there, we just assume it's positive and move on anyways, right?
This is 65.
Yeah, that's 65.
Oh, 67. Darn it. Let's try 67 then. 67. ln absolute negative 1 plus sine x over 2 plus sine x. And I'm going to take the derivative of that. So I'm going to move forward. First thing I'm going to do is I'm going to go ln absolute value negative 1 plus sine x times, subtracting ln absolute value of 2 plus sine x. So far so good? Okay. So derivative of the outside is just 1 over negative 1 plus sine x. Derivative of the inside is what? Cosine x. Minus 1 over 2 plus sine x times the derivative of the inside, which is cosine x again. Not much simplifying you can do there, so we'll call it a day.
Okay, cool. Thank you.
No common denominators. Yes, ma'am.
Wait, what's that first? I just can't read it.
Oh. Right, I just took what was on top and put it on the bottom.
Yeah.
Times cosine x. From the inside, right? So I did the outside, which is the ln, which means put it on the bottom. Then do the inside, which is just cosine x. Make sense? Okay. And then I do the same thing here. Now again, this is in large part a memory test. Because if you remember to flip things to the bottom, this is not hideously hard. It's going to take some, getting it into the memory. so that you don't get confused. And it gets worse because we're now going to do integrals in a moment, and then we're going to go backwards. Then we're going to make ln's, not make them disappear. That's going to get confusing. But you guys can handle it. Because you're AP scholars, and there's something in here that was funny I was reading. You are encouraged by how hard you work. Congratulations. There you go.
Wait, Mr.
All right.
That's Joe.
79. So we start with the hard one.
Dude, let's burn cats. No.
All right, here we go. We're going to take implicit differentiation on both sides. So what's the derivative of x, everybody? 1. What's the derivative of y? 1. Y prime, right? Because I took derivative the wrong thing. Derivative of 1 is 0, so that one goes away. What's the derivative of x squared plus y squared? ln. It'll be 1 over x squared plus y squared. That's the ln part. Times derivative of the inside, which is 2x plus 2y y prime. So now I got to get all the y primes on one side. Probably the reasonable way to do that would be to distribute this through. Go 2x over x squared plus y squared plus 2y y prime x squared plus y squared. Was that a question? I just distributed this through.
I minus.
Use the distributive property?
I minus y prime over there and then divide
Okay.
x squared plus y squared.
So then we move the y prime over here and the 1 over here. So I got y prime minus 2y y prime over x squared plus y squared, and that's equal to 2x over x squared plus y squared, that's an x, minus 1, right? You know, y prime's on one side. So again, strategy is make it all in terms of pluses, get all the y primes on one side. Then I'm going to do what next? Divide out the y prime. I'm going to factor. We call it factoring, but dividing is the right word.
Wait, I have a question. Why can you put that y prime on this on the step above?
Yes.
Why is it outside of the fraction? Is that allowed?
You can go.
Outside of what fraction?
The second to last step.
This one here?
There's 2.
It's the same thing.
I know, but
1 over 2y is the same as y over 2, isn't it? Yeah, same thing. Doesn't change anything. Yeah. All right, that's y prime, so I throw it at the bottom. Man, a fraction over a fraction. Are we going to really let, I mean, we're a calculus to it, but that's even a little ridiculous.
No,
2x over x squared plus y squared minus 1 over 1 minus 2y over x squared plus y squared. Are we really not going to simplify that?
I mean, I just got x squared plus y squared.
Oh, we got to plug in a point?
Yeah.
Oh, well, heck, we should have done it an hour ago.
Sorry.
1, 0. Well, we should have done that right here. That would have saved us about 16 steps. All right. I'm going to erase everything.
No.
Well, I don't like it.
Good learning.
Wasting time. Wasting time. Isolating variables. It's terrible practice. 1, 0.
Now we're just wasting more time, Reese.
What? No. 1, 0. So I put a 1 everywhere I see an x. I put a 0 everywhere I see a y. A 1 everywhere I see a y, right? Or wait, is that right? I switch it. Nope, it's a 0 here and a 1 here, right? So that just cancels out. I end up with 2 over here equals 1 plus y prime equals 1. The heck am I wasting my time with that other one? Simplifying that ugly thing.
So is that the slope?
That's slope. That's what the derivative is. So when the client, they want the equation.
you plug it into the final thing we got.
Well, it has to. Has to, otherwise we made a mistake. All right,
My final thing's right.
so y prime is so y equals 1x plus b. I plug in the point I've got, which is 0, 1, right? Or 1, 0. 1 times 1 plus b. B must be negative 1. So I get y equals x minus 1 is my final answer for that ugly problem that I